Ever pondered the enigma that is the limit of x times sin, 1x, as x tiptoes towards 0? Welcome to the heart of mathematics, where we'll unravel this riddle today. First up, we have the squeeze theorem. This theorem is our mathematical vice, sandwiching our function between two others that we know more about. In our case, we can squeeze x times sin, 1x, between negative absolute x and absolute x. Now, as x sidles up to 0, both these functions shrink down to 0 as well. So, by the power of the squeeze theorem, x times sin, 1x, must follow suit and also converge to 0 as x approaches 0. Our second approach calls upon the mighty L'Hopital's rule. This rule is like a mathematical superhero that swoops in to save the day when we're dealing with indeterminate forms. But remember, every superhero has its conditions, and L'Hopital's rule is no exception. It's crucial to ensure these conditions are met before we call upon its powers. L'Hopital's rule guides us through a series of steps, each time taking the derivative of the numerator and denominator of our equation. After applying L'Hopital's rule twice, we arrive at a limit that can be solved directly, either by hand or using another trusty tool like the squeeze theorem. And lo and behold, it evaluates to 0. So, whether you've squeezed or differentiated your way through, both roads lead to the same destination. The limit of x times sin, 1x, as x approaches 0 equals 0. In the grand mathematical scheme, this is a small but crucial piece of the puzzle. So next time you come across a problem that appears as perplexing as an infinitely large number multiplied by an infinitesimally small one, remember the tools in your mathematical toolbox. And always remember, every problem has a solution waiting to be discovered.